Alright guys, so this is going to be a video on using the WM-6000 series to check a fabricated or like a sheet metal part. In this case, this is a formed metal part. So I'm going to use the system now to compare a scan that I did of a part that we say was known good, but you could easily use a CAD model like a step file or an IGES file, maybe even a CATIA model, but here I'm going to be kind of almost comparing one part, live part, to another. To do that, we're going to open up the actual program here that's been created. The beauty of this system is that it is scanning. It does a lot of what other scanning systems do, but maybe a little faster with smaller file sizes, easier to manipulate, less horsepower you have to run it with, and also run mode. So you can actually scan a part and apply. In this case, we've got a ton of measurements here we're going to do. This customer wants to check this part for form to make sure that it's qualified, and you can already see all of the little points that they'd like to check lattice throughout. They've also got a very specific dimension here where they have to check from a known surface 2 inches down and check a diameter. We'd call that a gauge diameter. So we're going to be doing all of these things in a couple seconds. So the program's loaded, the system's ready to go. I'm now going to move over here to the probe screen. This is the scanner, of course. Right here it's telling us, hey, hit play to start. So when I hit play, it's immediately going to post for me a picture of what the scan should look like. And I can see that over there on the screen as well, but we're going to go ahead and just stay kind of localized here. When I hit play, it's going to lay down a violet laser. So it's already building, and it's a little harder to see with the video, but on the back of the screen there you can see as I'm building this scan, and it is quite fast. We're going to go ahead and get the surfaces that we need here. Now in this case, this part is actually kind of a small part for this system. I mean, we could do even smaller, of course, but this machine can measure quite large applications, if you like, from its single position with probing, which is contact based, can measure about 80 foot left to right max distance. And then this with the scanner has about a 35-foot cable, or you can run it wireless as well to about the same distance. So you can get into some very large applications if you want, but this part here is certainly perfectly fine. All right, so I think we've got just about everything we need here. If we need to update, we can. But here, one thing that's kind of cool is I can hit this view button, and I can actually kind of go in and inspect my scan data. And honestly, that looks pretty good. We're going to go ahead and hit stop, and then we're going to hit this check mark here. Doing two things at once, maybe. There we go. That's actually going to create a mesh or a connected polygon with all the points. We're going to set that down. Now this system does collect a ton of data like any scanner, but it actually does what we kind of have termed smart scanning by applying an algorithm that uses a unit of length on the a given area of the mesh. How well does that fit to a known geometric solid like say a plane or a cone? And if it's very consistent, it'll actually dial a lot of the points out of it. So it's constantly doing work to kind of dump points as far as making the files smaller. So when I scanned that, it was about 7 million points. And you can see here, it's only now 4.4. So it's doing a really good job of making the work a lot less on the computer that you may have to use. So that's already done, very quick. We're gonna go ahead and hit next here. And this gives me an opportunity to clean this. So I'm going to now use, what my favorite way to do it is just kind of select the body that I want to keep. And it'll kind of go through and say, okay, smart, highlight that, invert that to everything else, and just hit delete. Pretty quick. All right, and then now we need to tell the system, hey, here's how this was supposed to be fit. So this is a very geometric shape. If you had other features like datums, or maybe you didn't want to do a best fit alignment, you wanted to use coordinates, or again, datums based on a coordinate system, you could, but in this case, it's just got a very simple best fit alignment based on giving it kind of 3 key indicators. It's showing me where those points are supposed to be, so I'm going to kind of copy that. So I can see the first one, which is point 1, is right about there. Second one around the side here, there's point 2 is there. And I'm just kind of eyeballing it. That's totally fine. Kind of around the corner here to this hole for this one. All right, those match. We're going to hit what's called run alignment. And that's going to mesh the two together. And then finally, we're gonna hit OK, where it's gonna give us a preview screen just to kind of show us quickly how these two align. We're gonna hit confirm. And then finally, the system is gonna go through the process of doing all the measurements for us. We're actually at about 3 minutes and 45 seconds. And it's kind of keeping our time for us, but we're going to go ahead and see it just kind of hitting over and over. That's actually applying all the different measurements we want to do on this part. And then we're going to get some results here in just a moment. There we go. So we have a lot going on here. A couple of things quickly. You can already see the scan data kind of bleeding through in certain areas. So we actually can probably tell pretty quickly that this part is grossly different from the original. Now, when I come through here and start clicking on individual points, like a lot of software, you'll see individual readouts. So I can click on these independently. You can see that it's flagging those spots. Those are just compare checkpoints that I have installed, and then some of them are good. As I keep rolling through, you can see some of them are maybe not so good, and that would lead you to believe that, hey, yeah, the part's not good, but specifically where and how might be of interest. We can obviously roll through here and see what our different results are. One that's kind of interesting to call out quickly is just this 24.3 dimension, which is, again, a diameter that is set 2 inches down from this shelf surface here. So tricky to do with hand tools for sure. It's checking the diameter and the roundness of that. But more than that, we're gonna go ahead and say, okay, yeah, we know that the part's not good. There are certainly areas of the CAD comparison that are not great. But what does that mean? Well, if you go here to the scan menu, you can kind of reveal what's going on really at a tighter level. So we can go to the heat map, and now we can actually see what's really going on. This part is bent pretty badly, actually. So you have areas here that are not great, but if we come down here to some points, we can just click them here actually. Yeah, 50 thousandths there. And then here, 38 thousandths, and then maybe not quite as bad over here at about 23. On this side, even worse, 59 the other way. So this part is definitely bent, and you can even see that kind of in the middle there. You can change the tolerances on this heat map to kind of verify like what you'd like to see. You know, based on your tolerance, you could make it a binary, like tell me if the part is out by this far. If it's not, I really don't care. It's good to go. Or you could obviously analyze it a little further. But what's cool too is you can see that there's actually like a dent in the part there. There's another one kind of right here. So the system can also be used for kind of just detecting defects on a surface. Scanning is really great for holistic comparison of a CAD to a real part or part to part. So that's how it works with this system. That whole process took us, again, 3 minutes, 45 seconds to execute. That's a ton of measurements done and all in run mode. Very easy to teach a new user to do something like this. And then at this point, I would simply hit export report, print the report, and maybe go have a conversation about this part.